Okay, so now let's move on and talk about module number 4. Module number 4 is all about Chebyshev's theorem, z-scores, percentiles, box plots, that sort of stuff. So starting here, this first type of question, this is a classic type of Chebyshev's theorem type question that I like to ask on exams, where it's basically like a fill-in-the-blank type questions. Okay, so we have the average number of college-age students is 24.5 years old. So let me go ahead and write that. That's an average, so that's mu, 24.5. And the standard deviation, sigma squared, is 10. Okay, so at least there's a certain percentage there of college students are between 7 and 42 years old. Okay, so there's a range that we're between, at least a certain percentage is between. Okay, so if I were to draw this out, there's no assumption on what the shape of the distribution is. So a lot of times people will draw like a bell shape. You can draw that, but it doesn't necessarily have to be a bell shape. It can be any distribution, the age of these college students, right? And so let me go ahead and draw this out. So I have here in the center, I have the mean, 24.5. Now there's a lot of really young students, and there's a declining number of older students. Okay, so the shape of the distribution may look like something like that. Who knows, right? They don't say anything about the shape, but I'm hypothesizing it might have that shape. Okay, so between 7's way down here, and 42. Okay, so basically, what percentage of this distribution is in this area? What percentage of the distribution is there, right? 100% is between 0 and infinity years old, right? But what percent is between 7 and 42? Okay, at least what percentage, right? It might be more, but at least what percent, right? That's Chebyshev's theorem. Chebyshev's theorem tells you something about that. Now, Chebyshev's theorem for this proportion, this p, is 1 minus 1 over k squared. So you need to memorize that formula for Chebyshev's theorem. Now, what is k? K is the number of standard deviations that you are away from the mean, right? So how many standard deviations do you go below the mean to get to 7? How many do you go above the mean to get to 42? Well, z is a calculation for the number of standard deviations you are away from the mean. Remember, z is x minus mu divided by sigma. So I'll use the upper limit there. So 42 minus 24.5 divided by 10. So let's go ahead and pull out my calculator. And I will have 42 minus 24.5 divided by 10, 1.75. So I'm 1.75 standard deviations above the mean and 1.75 standard deviations below the mean. You could double check that. If I do 24.5 minus 1.75 times 10, right, I get 7, right, that's below the mean. And then if I do up from the mean, I get 42. Good, okay, so that worked. So k is 1.75, the number of standard deviations away from the mean. So 1 minus 1 over 1.75 squared. So let's go ahead and calculate this. Here, let me go to press clear. 1 minus 1 divided by 1.75 squared. All right, I get 0.64 or 0.67. All right, so now to change that into a percentage, actually, let me go ahead and round that slightly further. So I'll round to 4 decimal places, so 6, 7, 3, that 4 rounds up to a 5 because that 6 is there. Okay, so that becomes a 5. So 67.35, right? To change it to a percentage, what do? I multiply it by 100, right? So I get 67.35. All right. At least 75% of college students are between. Now I have to figure out what the range is, right? So I have the percentage now. I have P. So if I draw this out, I need to go a certain number of standard deviations above and a certain number below to figure out this range. right? But I know now this is 75%. Before I didn't know what this was, and I figured it out. It's at least 67%. Now I know it's 75%. Okay, and I want to figure out the other way around, right? So I know that this is 0.75. P is 0.75. And basically now what I want to know is what's K. Okay, so I'll solve this equation. So let me go ahead and add 1 over K squared to both sides and subtract 0.75 from both sides. So I get 1 over K squared equals 0.25. 0.25 is the same thing as 1 over 4, right? So now flip both sides. So you get K squared equals 4. All right, so what's K? K is 2, right? It's plus or minus 2 technically, but the number of standard deviations away from the mean is always a positive number. Number of standard deviations count, right? So we count positively. Okay? So we're 2 standard deviations below the mean and 2 standard deviations above the mean. Okay? Well, a standard deviation is 10, so basically 20 below and 20 above. All right? 20 below brings me to 4.5, and 20 above, right? So 24.5 plus another 20 is 44.5. All right. Okay, so that's the Chebyshev theorems type problem. You should feel comfortable with that. Definitely be a problem like that on the exam. All right, Matt is 32 years old. Find the z-score corresponding to Matt's age. So now you need to know the formula for z-score, okay? This is something you need to memorize. Actually, the z-score formula, it might be on your formula sheet. It is there under chapter 6, normal distribution. Okay, we'll be talking more about this, but if you do forget the z-score formula, it is there. Okay. All right. So what's x here? X is Matt's age. Okay. The mean is still 24.5, and the standard deviation is still 10. I wrote that is sigma squared. Standard deviation is sigma, right? So that was a mistake I wrote there. So standard deviation is just sigma. Variance, remember, is sigma squared. Okay. All right, so that's divided by sigma. Good. All right. So let's do this. 32 minus 24.5. And then take that and divide it by 10. What do you get? 0.75. All right, so David now has a z-score of 1.553. How old is David? So now basically I need to find x. They've given me a z-score, and I need to find the corresponding age to that. So multiply both sides by 10. Okay. Add 24.5 to both sides. So 15.3 plus 24.5. Okay. Doing some algebra. And what do I get? X equals 39.8. So he is 39.8 years old, David. Okay. More questions on z-score. Sarah earned a 79% on her physics test, which had a class average of 75 and standard deviation of 10. Okay. Mary had an 81% on her chemistry test, class average of 78 and standard deviation of 5. Find the z-score for Sarah's test. Okay. So z equals x minus mu divided by sigma. Sarah got a 79, so that's x. Her class average, that's mu, 75, and the standard deviation was 10, right? So that's basically 4 divided by 10, right? So 4 divided by 10 is 0.4. Okay, Mary, for her z-score, she scored an 81, so that's her x. Her average was 78, and her standard deviation was 5. Now, if you change these to 0.79, 0.75, 0.81, 0.78, 0.10, 0.05, you'll get the same answers, right? So that's just basically dividing everything by 100. You'll get the same answer when you take the fraction. Okay. So it doesn't matter which way you do it, just as long as you're consistent. So 3 divided by 5 is 0.6. Who did better on their test relative to the class? Okay, so basically, we don't know the distribution, but we know Mary, 78 was in the middle. She got an 81. That's 0.6 standard deviations above the mean. Right? Sarah, the middle was 75. She got a 79. That is 0.4 standard deviations above the mean. So who's higher above the mean? Mary is. Mary's higher above the mean, right? So she did better relative to her class. Okay. All right, so now moving on to finding percentiles, box plots, that type of stuff. So Robert is 51 inches. Find Robert's percentile. So remember, a percentile is basically the percentage that's less than. Always think less than when you think percentile. So the percentage that is less than. Okay? So how many people are less than 51 inches? 1, 2, there's 2, 3. So 3 out of 7. So percentiles, we usually go ahead and multiply that by 100, right? Because it's percentile. So 3 divided by 7 times 100 is, I'll go ahead and round that to 43. 43rd percentile. Okay? So Robert is in the 43rd percentile of this data set. Okay, find the 70th percentile. So when you're trying to find a percentile, that equation L is helpful. That tells you the rank. Okay, this is an equation you should memorize. Helpful formula. K is whatever percentile you're looking for, divided by 100 times the sample size, which is 7. So that's basically 0.7 times 7. Okay, 4.9. Now always round L up so this will be the 5th observation. L is always an underestimate of the rank of the percentile, right? So even if it came to 4.1, you'd still round it up to 5, right? You always round up for L. All right, so the 5th observation. Now, it's not just 1, 2, 3, 4, 5. I have to sort the data, okay? So let me go ahead and do that first. So I have 34, 36, 47, 51, 62, 66, 67. Always double check. 1, 2, 3, 4, 5, 6, 7. I have same number of data points. So 5th observation would be 1, 2, 3, 4, 5. 62 is the 70th percentile. All right. 5-number summary. Right? Now we're going into box plots. All right. So let's find the 5-number summary. So 5-number summary is the min, the first quartile, the second quartile, the third quartile, and the max. I always like to fill out the min and the max first because they're the easiest, right? And this data is actually already sorted. So the min is 1.7 and the max is 4.2. Okay, first quartile. Go ahead and use your equation. It's just 25th percentile. How many data points I have? 27. So it's basically 0.25 times 27. I get 6.75. Okay, so go to the 7th observation. 1, 2, 3, 4, 5, 6, 7. 2.5. Okay, let's do the second quartile. So basically 0.5 times 27. 13.5. The 14th observation. So that's the 7th, 8th, 9, 10, 11, 12, 13, 14. So 2.7. Then lastly, the third quartile, 75 divided by 100 times 27, or 0.75 times 27, 20.25. Okay, remember always up, so that's the 21st, right? Even though it's 0.25, L is always an underestimate. Okay, so 21st. So this was the 14th, 15, 16, 17, 18, 19, 20, 21, 22. Oh, 21. Stop at 21. Right. So that's a 30. 3.0. So that is the third percentile. All right. Are there any outliers? Okay. You need to know the formula for outliers. Okay. So first thing you do is you calculate your IQR, your interquartile range, Q3 minus Q1. Okay. So this is another formula you must memorize. Okay. So 3.0 minus 2.5, which is 0.5. Okay, so that's the interquartile range. Then, to find an outlier, you do the lower bound, which is the first quartile minus 1.5 times the IQR. Okay, so first quartile minus 1.5 times 0.5. Okay, so 2.5 minus 1.5 times 0.5, 1.75. Okay, and the upper quartile, or upper bound, will be the third quartile plus 1.5 times the IQR, right? So 3.0 plus 1.5 times 0.5, 3.75. So anything between 1.75 and 1.375 is considered not an outlier. Anything outside of that is considered an outlier. Okay? So do I have any data points that are outside of that? Yes, right? This lowest number, 1.7, is outside of that. And 4.2 is also outside of this. Right? 3.6 is inside. And 2.0 is also inside. So we're good with just these two that are outliers. So what are my outliers? 1.7 and 4.2. All right, so now when I'm constructing my box plot, I'll say 1.5, 2, 2.5, 3, 3.5, 4. Okay, so my box plot now, I'll have bars for each of the quartiles, okay? So 2.5 will have a bar. Let me go ahead and label it as 2.5. 2.7 will also have a bar. And 3.0 will have a bar. And that is my box. Okay? Now, my min, my whisker, won't go to the min to 1.7 because 1.7 is an outlier. Okay? Rather, it'll go to the next observation that's inside. So that'll be 2. So 1.7 will be noted with a dot. Okay, that's what makes this a modified box plot. So we're modifying it based off the outliers. Okay, the max here won't go to 4.2 because that's also an outlier. Instead, it will go to the next observation inside, which is 3.6. Okay, so that's 3.5. So 3.6 is right here. Okay, and then we'll mark 4.2 with a dot. All right, so that is my box plot. All right. All right, I'm going to go ahead and make one last video for Module 5. So I'm going to cut this one here, and I'll start the next video for Module 5.